In this video, I'm going to explain the quotient rule for exponents in two different ways. Here's the first way. Let's say we have x to the fifth divided by x squared. How do you do this? Well, you subtract the exponents. That's the trick here. And you get x cubed. That's the answer. Let's do another one. Let's do y to the 20th divided by y to the 13th. Once again, you subtract the exponents and you get y to the 7th. Let's do one more. Let's do t to the 67th divided by t to the 19th. Once again, subtract the exponents. And what is 67 minus 19? I think that's 48. Yeah, so the reason why you can subtract the exponents here is because the bases are the same. So here the bases are both t's, here the bases are both y's, and here the bases are both x's. But let's explore that a little bit further. So think about this. X to the fifth is really like x times x times x times x times x, right? X to the fifth is 5x's being multiplied. That's literally what x to the fifth means. Okay, and x squared is x times x, right? 2x's being multiplied. That's what x squared means. Okay, well, we can cancel some of these common factors. We can cancel some of these x's. So there's a pair of x's we can cancel. There's a pair of x's we can cancel. So how many x's do we have left over? We have 3 x's left over that are being multiplied. So that's the same thing as x cubed, which is our answer. So we basically just checked our work here, but I think by writing out all the x's, you can kind of see why subtracting the exponents works. Subtracting the exponents is like a fast way of like counting the x's that are left over, right? Subtracting the exponents is like a super fast way of counting up all of the remaining x's. Here's the second explanation. Let's say I have 2 to the 5th power divided by 2 squared. What does that equal? Well, I don't know. I have to know what 2 to the 5th power is, and what is that? So I know 2 squared is 4, so I'll just write that first. Okay, and then 2 cubed, I guess that's 4 times 2, so 8. 2 to the 4th, that would be 8 times 2, so 16. And then 2 to the 5th is 16 times 2. I think that's 32. Let me just see. Yeah, it's 32. Okay. So this is 32. And then 32 divided by 4 is 8. Okay, so there's the answer, 8. I had to do a little bit of work, but I got the answer. It's 8. Okay, but there's another way I could do this problem, probably an easier way, and I'm going to show you it now. I'm going to subtract the exponents. So I do 5 minus 2 in the exponent. That is a 5. That is a 5. 5 minus 2 in the exponent. And I get 2 cubed. And what is 2 cubed? 8. You get the same answer, right? 2 cubed is 8. So we get the same exact answer. So yeah, subtracting the exponents works, right? It gets you the correct answer. Okay, so what if we had letters involved? Let's erase all of this. But what if we had letters involved? So what if I had like x to the 5th divided by x squared? Well, it's the same exact idea, right? We can do the same thing we did here. And you might be thinking, but wait a minute, here we have letters. How come we can do what we did here, even though over here we're dealing with letters? But remember, in math, letters are supposed to be numbers, right? Letters are supposed to be numbers that we don't know. Letters are supposed to be like mystery numbers. So if if there's a cool trick that works here, then why wouldn't it work here, considering in both cases, we're just dealing with a bunch of numbers? So it does work. The trick does work. We can subtract the exponents and we end up with x cubed. And that is our answer. And that is the correct answer. Thanks for watching.